right, so now let's take a look at this second function. So I have x minus 1, but my restriction is x has to be greater than 3. So I would start here at minus 1, and I have a slope of 1, so it would go up like this, or go in the opposite direction, and my function would look like this. But if I have a restriction that x has to be greater than 3, 1, 2, 3, I'm going to erase this part of my graph because it is not valid. And 3 itself is not actually a part of my solution. So I have to put an open circle at 3 because it's not less than, it's not greater than or equal to 3. It's only greater than 3. So I have to have an open circle there. Now I'm going to graph y equals 2. That's my next function, but I'm going to graph it between -1 and 3. But again, I'm going to have open circles because these are not equal to, it's just less than. So I'm going to have an open circle at -1 and an open circle at 3, and I'm going to just put a little line between them. And my last function is going to be less than -1, less than or equal to -1. So -1 would be part of my solution. But I'm going to have 2x plus 4. So 1, 2, 3, 4. I'm going to go over 1, down 2, down 2, over 1, and I'm going to, my slope is going to be rise over run. So down 2 over 1, down 2 over 1, and I'm going to have my function going like that. I still have this open circle here. This never got colored in from any of the functions. So this means I have a hole in my function. And the hole is at 1, 2, 3. It's at positive 3, 2. So I have a hole at positive 3, 2. That means that this is a discontinuous function. Right? Because I can't, this domain and range would not be valid for this particular function. So now it says, let's evaluate y of -2. So we always start from the inside out. So let's just start here. Let's find out what y of -2 is. So the first thing we have to do is find out, well, which one of these functions is valid at -2? Well, -2 is greater than 3. That's false. -1 is less than -2 is less than 3. Well, that's false. -2 is less than or equal to -1. That's true. So I'm going to take -2 and put it in here for x. So 2 times -2, a little more room here. 2 times -2 plus 4. This would be -4 plus 4, so that's going to equal 0. So y of -2 equals 0. So this tells me that this stuff equals 0. So now I have to find out what is y of 0. So I have to go back up to these functions, and I have to say, all right, where is it valid at 0? Well, 0 falls between -1 and 3, so it's going to be true for this particular function. So at this function, the y value is 2, so I know that this would equal 2. All right, let's try another one. All right, so once again, we're going to graph our functions. We have the absolute value of x plus 1. We know this is going to be a V graph, and we have a vertical shift of 1. But my function is only valid where x is greater than or equal to -1. So I know my graph would normally go up and over like this, but I know now that it has to only go in one direction. So it's going to go like this. So that would be my first graph. Now my second graph is f of x is 2 or y equals 2, but it's only valid when x is less than -1. So I would have a open circle, which doesn't really matter because it's already colored in from my first function, and I'm going to be going in this direction. So now this is going to be a continuous function because all my x values here are colored in. I have no holes. And then it said, let's find f of -4. So let's first find f of -4. We're going to work for the inside out, so we're just going to figure out that piece. We have to go back up here and find out which one of these is valid at -4. Well, -4 is not greater than or equal to -1, so that's not true, but -4 is less than -1. So I know f of -4 has to be 2 because that's the only value given here. So now that I know that this is 2, I have to find out what is f of 2. So we're going to go back up to these functions. 2 is greater than or equal to -1, so it's going to be true for this function. So I know this is going to be the absolute value of 2 plus 1, which is 3. So now I know that f of -4 equals 3. So you just discover which one of these is valid at that number and then use that number to figure out what the expression would equal. And on the last one, we have 4 lines, y equals 5, y equals 4, y equals 3, y equals 2, but we have to think about all these restrictions. So 1, 2, 3, 4, 5, but I have to start at 4 and it has to be greater than 4, so it'll go in this direction. Here I'm only going to draw it between 2 and 4. So here's 2, but 4 is going to be an open circle, so it's just going to be a little one like this. And I'm going to draw y equals 3, but it's going to be between -1 and 2. -1 is a closed circle, but 2 is an open circle. And I'm going to do y equals 2, but it's going to be less than -1. So it's going to be in this direction. So I kind of have these stairs. So I see that I have some holes here. However, those holes kind of get filled in by the function above it. So even though I have a hole here at -1, -1 is valid at this one. I have a hole here at 2, but it's valid here. And I have a hole here at, what's that, 1, 2, 3, at 4, but it's colored in on this one. So this is a continuous function. And now let's figure out what is y of 3. So once again, let's go to the function and let's first figure out what is y of 3. Well, 3 is between 2 and 4, so I know that y of 3 is going to be 4. So now I have to figure out if this stuff is 4, I have to figure out what is y of 4. Well, 4 is greater than or equal to 4, so that means I'm going to use this function, so I know that that's 5. So that tells me that y of 3 will equal 5. If you have any questions, let me know.